so for this is y equals to 3 minus plus 5. The remainder is 5. Plus 5 over x minus 2. Okay, so by now you all should know that with this there should be a horizontal asymptote of y equals to 3, as well as a vertical asymptote of x equals to 2. Okay, there is here and there is an intersection here. This is half and this is 1/3. Okay, by doing mental calculation of letting x equals to 0 and y equals to 0. Okay, so the next part, what happens if the graph needs to add a value of k? Okay, basically it will translate k units along the along y axis. Asymptote will move up by k. So this guy will become y equals to 3 plus k. The x asymptote will not change. So this guy is x equals to 2 still. Okay, so the whole graph will move up by 3 units. Remember, the x coordinate will not change. So this is half plus k. This guy will still be 1/3. Okay, if we minus k, means it translates negative k units downwards. The x asymptote will not change. Okay, the asymptote may be above the axis or it may be below the axis. It depends on how big your k is. But I'm going to just write down y equals to 3 minus k for this. Okay, yeah, and it will this is half minus k, but the x will still remain. So this is translate a negative k units along the y-axis. Okay, so there's two things about transformation that you have to know. Number one, are we making change to the y? If we are making change to the y, it all makes sense. One, that means plus means move up, minus means move down. Okay, but if we are making a change to the x, that's where the whole thing is going to be a bit counterintuitive. Okay, can if you see a y equals to fx plus k, can you see the plus k is to the x inside? In this case, it is a translate. Translate means move, but it's an opposite direction, negative k units along the x-axis. That means it moves to the left. Okay, so when it moves to the left, the vertical asymptote will move to the left. X equals to 2 minus k. It moved to the left side. Understand? But the y asymptote doesn't change. Okay, so this guy will become here. You may need to find out what is here, the y-intercept, but it doesn't matter right now. And then this guy will become here. The y-intercept become 1/3 minus k. So when you see f of x plus k, it means move left. When you make changes to the x, it will always change the is always opposite way. Okay, so f of x minus k, this is to translate k units along the x-axis. Okay, so that means it moved to the right. So it moves to the right, the vertical asymptote becomes x equals to 2 plus k. The y asymptote doesn't change. Okay, it goes here and it goes here. Okay, the y-intercept become 1/3 plus k, whereas the x remains at half. Okay, so if you see f of x minus k, it moves to the right. So you are making changes to the x. So these two different things. The left side is making changes to the y. The right side is making changes to the left. Yes, opposite. Okay. Where? Oh yeah, of course there is the other curve here. Okay, can. So if you go and see, scaling means we stretch. Another word for scaling means to stretch. Okay, so when you multiply a in front, you are scaling a units along the y-axis. That means you make it bigger with respect to y. Again, everything that is with regards to y we change. So the y asymptote, the horizontal asymptote becomes y equals to that was 3, right? 3a, but the x asymptote is still going to be the same. X equals to 2. The graph is here. The y-intercept is going to become half times a. The x-intercept is still the same at 1/3. Okay, but if you do 1 over a, okay, this will become a smaller graph. If you scale 1 over a units along the y-axis, the whole graph will actually become smaller because the asymptote from y equals to 3 now becomes y equals to 3 over a. Okay, the x doesn't change. This will go to here. This will go to here. The x-axis become 1 over 2a. The a is a denominator. Okay, so when you times 1 over a, the whole graph becomes smaller. Okay, however, when you multiply by 8 to the x, again, it's a different thing. So in this case, it's a scale of, it will actually become smaller, 1 over a units. But this time is along the x-axis. Okay, so for here, the x asymptote will become x equals to 2 over a. The y asymptote doesn't change. Because it was half times 1 over a is 1 over 2a. The a is below. Half times 1 over a. You multiply to the initial one was half one. It's half a, half times a. The a is on the outside and the a is the denominator, is different thing. Okay? In this case, this is still half. This guy was 1/3, right? 1/3 times 1 over a. So this guy is like 1 over 3a. The a is the denominator. So the whole graph will actually become smaller. This graph will actually compress. Okay? A very easy question to understand, a very easy way to understand, right, is like y equals to sine x. Y equals to sine x is from 0 to 2 pi. Okay? When I draw y equals to sine x over 2, you don't have to draw for this. What happened is actually just half a cycle. Can see? So the whole graph gets bigger when you divide by 2. But when you multiply by 2, y equals to 2x. Then there will be 2 cycle, right? Means the whole graph compressed. This one don't need to copy, but at least understand can. Okay, so in this case, this is a scale of a units along the x-axis. Okay, that means when you times 1 over a, the whole graph will actually look bigger. The whole graph will actually look bigger. X equals to 1 over, x equals to 2a, the y is still 3, there is a graph here, and then there's a graph here. This guy is 1 over 3 times of A. Okay, later I come to you. So when you multiply by, so remember when you make changes to the x, it's always different. Okay? No lah, quickly draw lah.
Not bad, I draw like numbers, not bad. I think it's pretty good.
The second quadrant not so good. Like this better. Like don't go so close. Go out a bit. Understand? Yours is like, I go until here then turn, you know what I mean? Okay? Can? The next one is called a reflection. If the negative is on the outside, I reflect downwards, which means I reflect on the x-axis. The x-axis is my reflection. Okay, draw the normal graph, draw the graph on top, which is like this. Here and here, first quadrant and third quadrant. Okay, so when you do a reflection, right, the y asymptote, right, from y equals to 3, it will become y equals to negative 3. But the x asymptote will not change. Okay, so this will become this way, and this will become this way. So this will become negative half. Y equals to negative 3. Understand? Okay, but if you make a negative, this is called reflect left, which means you reflect on the y-axis. It becomes x equals to negative 2. Okay, so it becomes this side and this side. So this is negative 1/3 and half.
You must put it like find all the points first. Different point then draw.
You know the transformation is easier. The one that you didn't know. Later I see. Move first. Move first. Go ahead. Yeah, later I think of it. Okay. Now when you have a composite transformation, right? Okay, when you need to do composite transformation, right? There are two ways to do it. Okay. There are two ways to do it. For example, if I want to get from fx to become f of 2x plus 3, okay, the first step I do, if I do scale first, that means if I make it to become f2x first. Lucius, can you describe to me the transformation? Scale of how many units? No lah, because it make changes to the x. So it's a scale of half units. And it's along the x-axis. Okay? Huh? Yeah, it goes this way, correct. It goes smaller. Okay, now look here first. If you make changes to the x already, right, you want to make it to become plus 3, you cannot plus 3 like that. Okay, because whatever you make changes to the x, right, it exists in a bracket. So in order to become fx 2x plus 3, right, you must say that it's 2 of x plus 1.5 because you are making the change to the x. Understand? So that if multiply by this, then it becomes f of 2x plus 3. Okay? And then in this case, what is this? If your x plus 1.5 is a translate of how many units, Lucius? Negative 1.5 units along x-axis also. Okay, this method is not so preferred, but you have to learn the concept that if you make changes to the x, it must exist in a bracket. So if you times 2 in front, right, to the x, right, you cannot just times 2. Or rather, if you want to plus 3, you cannot just plus 3 to the 2x. You have to plus 1.5. It's always easier to translate it first before you scale. This is scale before translate, not the best. Translate before scale is easier. Plus 3 first is easy. Fx to become fx plus 3 first. Okay, Angelina, what's the transformation?
3 along the axis plus at 3 along.
Totally wrong.
Oh wait, minus.
Translate
Axis.
negative 3 units along x-axis. Then now you do a scale of half unit.
Then it doesn't affect the string.
Doesn't. Okay. Okay, these two a bit tricky. Okay, when you need to modulus the fx. Okay, you see a modulus on the outside. Okay, the technique for this guy is write down clean everything below the x-axis, or rather reflect everything that is below the x-axis upwards. Okay, again this was our fx graph. Okay, it will become okay, so anything below it will be reflected upwards. It will become this way, and then it will go up. Can see? This part here is reflected. Reflect this part upwards. Not easy skill, to do this. After quite long, then you will know how to. Okay.
Where to find the x intercept?
The x-intercept is still the same one, 1/3. Why would it be different? It's 1/3. Still the same one.
You find points, man.
It's still the same. All these points we already know. Okay. But if it's f modulus x or clean, or rather reflect right hand side to left hand side. Okay, this one like that. So be careful. I need to reflect the right hand side to the left hand side. The asymptote will be reflected. Okay, this part right is going to be, this is not curve, it's a sharp like that because it cuts here. It's sharp. This part is super important. This part is sharp. Must know when the point of reflection is sharp. Okay, the point of reflection is always sharp. It's not a quadratic, it's a sharp one. It means that the sharp, it doesn't turn. It's a sharp place. Okay? Then the next part, which is the reciprocal graph, are not so important yet.